All right, let's go ahead and do this back part. Zero product property means we're just going to find the zeros once we're done factoring, but we're going to still use the same things. So here I look and I check for a GCF because it looks kind of tricky otherwise. And I see that I can divide out a 3x from each of these. So that becomes my outside factor. These three cancel, leaving me with 1x because 2 minus the one I took away. And then minus, and then here, 15 divided by 3 becomes a 5, and the x's cancel out. So what are my zeros? Well, what makes 3x equal 0? Only if x is 0. And what makes x minus 5 equal 0? Only if x is 5. This has two pieces. They don't have anything in common, so I look to see if it's the difference of two squares. It is a difference. This is the square of x. This is the square of 7. So my factors become x plus 7, x minus 7, and each of those will equal 0 if you use a negative 7 for this one or a positive 7 here. Here I have 3 pieces and a 1 in the front, so I'm going to look at unfoiling this. So I'm using my yellow chart on the 12. So I have 1 and 12, 2 and 6, 3 and 4. I need them to add up to 13. This also indicates that I'll have the same signs in both of my factors. The only one that adds up to 13 is 1 and 12, and the only way to make it positive 13 is if they're both positive. So my factors are x plus 1, x plus 12. To make each 0, here I would need a negative 1 for x, and here I would need a negative 12, because you're simply saying what makes x plus 1 equal 0? Negative 1. And then same with the 12. Here I have 3 pieces. There's a 1 in the front, so I'm only splitting the 16. I go to my yellow chart, and I have these options. This is negative, so they need to subtract to be 6, and it means that I'm going to have different signs when I go to do my factors. One's going to be positive and one's going to be negative. The only pair that subtracts to be 6 is 2 and 8, so I'm going to end up using a 2 and an 8. And then to get my 6 to be positive, I'll need a positive 8 minus 2. To make this equal 0, x would have to be negative 8. To make this equal 0, x would have to have a value of positive 2. I have 3 again, 1 in front, so I'm only splitting my 72. So going to my yellow chart, I'm going to have a lot of options here. 1 and 72, 2 and 36, 3 and something. How many times is that going to go in there? 3 is going to go in there. 1 time, help, 2 times. Okay, that's right. And then, I don't know. I know that I'm going to get to 6 and 7. Sorry. That's going to be the one that I need because they also subtract to be 1. So when I go to write this out, the negative is also telling me that they're going to have different signs, 1 plus and 1 minus. I need my 6 and my 7, but together they have to make a negative 1. So I would need negative 7 plus 6 to get that negative 1 in the middle. And then the zeros for each will be whatever makes this 0, which is a positive 7, and whatever would make this 0, which is a negative 6. Another one with 3, 1 in front, splitting 50 in a way that adds up to 15. This is positive, so I'll have the same signs. Off of my chart, 1 and 50, 2 and 25, 5 and 10. They need to add up to 15, so I'm going to use these two. So I'm going to have a 10 and a 5, and then to make them negative 15, they'd both have to be minus, because minus 5 minus 10 more. Plus, I knew they were going to be the same sign because that was a positive at the end. To make this into 0, I'll need a positive 5, and to make this into 0, I'll need a positive 10. All right, now I have a number in the front, so I have to use kind of that cheaty method that I showed you guys in class where I'm going to have to reduce later, but for now I leave a 3x here and here. I multiply the beginning and the end so that I'm not ignoring the 3. Then I go to my yellow chart like normal. I need them to add up to 5, so that's going to require me to use the 2 and the 3. I need the 5 to be positive, so I'll need them to both be positive. Plus, this was a plus, meaning they would be the same sign. And then whenever you use this kind of cheating way to go about it, something's got to reduce. 3 and 2 don't have any common terms that could come out, But here you could divide both pieces by 3 and get an x plus 1 because 3x divided by 3 is x and 3 divided by 3 is 1. The zeros for this one, it's going to be -1 because I'm just saying x plus 1 equals 0 when x is -1. This one you might need to write out, and then you would take away the 2, and then you would divide by 3. So those are my two zeros. Here again, I have a number in the front, so I'm going to end up writing it twice and then reducing it later. 2 times 7 is going to be 14. So 1 and 14, 2 and 7. Now I need them to subtract to be 5. So I need to pick 2 and 7 because they make the 14 and they subtract to be 5. Forgot to write the 2x here. Keep in mind that negative here tells me that I'll end up with opposite signs, one positive, one negative. I need a -5, so I would need to have a -7 plus 2 to make that happen. And then because I am doing one where a is not 1, I'll need to reduce. 2 and 7 do not have anything in common, but here I can divide both pieces by a 2, reducing it to 1x plus 1. This one I can find pretty easily. This one I might have to actually set equal to 0 and solve my way through to decide that the 0 for 2x minus 7 is positive 7 over 2. And then, okay, aren't there any that are grouping? That's not awesome. I'll see if I can find some of those to do in class. So here, this is a 7. And so I'm going to have to put a 7, here and here. And then I'm going to be splitting a 21. My options from the chart are 1 and 21 or 3 and 7, but I need them to subtract to be 20. So I'll use a 1 and a 21. To get a -20, I would need -21 plus 1. Something has to reduce, and in this case, it's the second one. So I get 7x plus 1 and 7x minus, I have to reduce it. If I divide a 7 out of each of those, I'll just have 1x, and then 21 over 7 gives me a 3. So the 0 for this is 3, and for this one, if I need to write it out to be more confident, I can. So my x would have to be -1/7 for that one to be 0. Let me see if I can find some grouping problems in a previous worksheet, because how are there no grouping problems? Okay, here. So this is back on, I don't even know what day. This packet is kind of messy in my opinion, but let me just show you so you have an idea of how to do these. I'm going to split this into 2 parts. The highest number of x's I can take out over here is x squared. So that will leave me with 1x here because I'm dividing out an x squared from each of these. And then plus 2. Now this 9, this negative has to come out, and then I can see that 9 is the thing these two have in common. So if you divide a -9 out of each of these, this becomes x, and -18 divided by -9 becomes a positive 2, which is good because these two should always be the same. And then these two form the other factor. Now this one is a difference of 2 squares because this is the square of x and this is the square of 3. So ultimately my factors are x plus 2 and then x plus 3, x minus 3. So my solutions or zeros are going to be all 3 of these numbers. And then here too, split that in half. Looking at these, the thing that comes out is an x squared. If you divide an x squared out of each one, that's kind of crowded. Then I would have x minus, and here all the x's cancel, 3. Again, there's a negative, so I have to take that out along with the number that comes out, which is a 4. Dividing -4 out of each piece, I end up with 1x, and then here a -3, which is good because these two are the same, so they go as one factor, and then these two make the other factor. But just like in the previous example, this is the square of x, this is the square of 2. So I end up with my x minus 3, and then the other one breaks down to x plus 2, x minus 2. So I end up with a 3, a -2, and a +2 for my zeros. So those are all the kinds of factoring methods that you are going to see. Hopefully that helps. Bye, guys.